Good morning, good afternoon, and good evening, wherever you are. And welcome to day 5 of our 12 days Geospatial Python Bootcamp. As I sent earlier to the chat room, there's some renovation going on at a nearby office. And so if the microphone is not able to cancel the noise out of it, I'm sorry, but I will try and then edit it before I put it up on YouTube if the noise still exists when I download it. Thank you. So today we are introducing ourselves to Geopandas and how we can use it specifically for vector geoprocessing in Python. That is geoprocessing of vector files plus other amazing stuff that it can do, because Geopandas looks like one package that encompasses almost all, and it can do several amazing things, which we will find out very, very soon. Okay, so let us quickly take a look, as always, at our agenda for the day. So today we will introduce ourselves to Geopandas, and then we will read and write files with Geopandas. We'll also see how we can do some plotting and interactive mapping also with Geopandas, plus other things. So let us get into VS Code and get started with it for today. Okay, and let me come to full screen. Okay, so Geopandas, maybe we should visit their website also. So here I can just search for Geopandas docs, short for documentation. And this first one here pops up. So I can open this link. And once again, if you're a beginner, I know that if you're a beginner, this is not the best place to be. But that is why this bootcamp is here. I'll take you through it one after the other. So this is it. I just wanted you to see the website. I'm looking at, okay, let's go to the home. So Geopandas is an open source project to make working with geospatial data in Python easier. It extends the data types used by pandas. I think the series and the data frame, we'll get to that one, to allow spatial operations on geometric types. And so it uses Shapely, and behind the scenes, it also uses Matplotlib, Fiona, and this one, whose name is a bit difficult for me to pronounce, PYOGRIO, and a lot of other stuff behind the scene just to make your geospatial analysis very, very cool and very, very fun. So let us get back to our VS Code. Okay, so in order for us to get started with Geopandas, there's one thing that I have to let you know. Let me select my kernel. Is that you know the difference between what we call a GeoSeries and GeoDataframe. Okay, so these two here, a GeoSeries and a GeoDataframe, are the basic, should I say, the basic building blocks of Geopandas. If you have understanding of this, then you have no problem or very little stress using Geopandas. And so what is this GeoSeries and GeoDataframe? Well, let's go back to the documentation. If we go to, okay, that will be a bit, let me see, let's come to getting started. And it was not there, so maybe the about Geopandas will do. Okay, so this is what I'm looking for. It currently implements, this line says it currently implements GeoSeries and GeoDataframe types, which are subclasses of Pandas series and Pandas data frame. We can check those ones up in the Pandas documentation. If you have been doing any kind of data analysis or even data science, you should be familiar with the Python Pandas package. But we will not even bother ourselves looking at the documentation once again. The things that we might see there might not really be familiar or easily comprehensible, given that we are looking at things from the beginner's perspective. So I will give a very simple explanation of what a GeoSeries is and what a GeoDataframe is. Not the very technical definition, but something that is still the meaning of it, but in a very less technical way for you to grasp whatever we are doing today. Okay, so a GeoSeries, think of it as it is like a list. You know a Python list, if I come here, so let me just say series, and I can set this list equal to anything. I can just put 1 and then 2, anything in here. This is a Python list. I'll bring up this here is a Python list. So think of GeoSeries, even if you have not used Pandas before, think of it like a list that can store items like this. But because this is a geo, when we say geo, it looks like it's talking about a particular space, and that space also relates to the Earth. So the word geo is more or less talking about something that relates to the Earth. And as a geospatial person, you also know that you are talking about the place where we can do geometric computations and all. So a GeoSeries stores a list, but instead of storing numbers or let's say texts or other data types, it stores geometries. Remember when we introduced ourselves to Shapely, we found out that we have 3 basic geometric data types, which were points, lines, and polygons. So think of a GeoSeries as a list, a Python list defined by an open and closing square brackets. And then inside here, instead of numbers or words or anything like that, you have geometries in there rather. So if I should quickly define, so okay, let me define one GeoSeries. So I will have to import Geopandas. Usually it is imported with an alias of GPD, but you can choose not to do this one. It is completely optional, GPD. And because you are about to store geometries, let me from Shapely.geometry also import. And for now, let's look at points. And so if I want to define a GeoSeries, what I'll do is that let's say places, which is the name of my GeoSeries. What I have to say is gpd.geoSeries. I will not just open and close square brackets like I do in Python, but I'll open a GeoSeries object, which is gpd.geoSeries. Or you can also say from Geopandas import, and then you can import the GeoSeries also from here. If you do it this way rather, then you don't need to bring the GPD. It will work like this for you. Okay. Either way is correct. So let me leave this second one, or maybe let me. Okay, no problem. So inside the GeoSeries now we can open the square brackets, which is the list. And then here, let me just say I'll put points. I told you that it takes geometries. So I can put a point of say 1, 2, which is X and Y. I can put another one, which is maybe a point of 2, 3. And then maybe a last one of 3, 4. Okay. So this is my GeoSeries. If I print places, I'll see that the data type is geometry, and all these ones are also in here. So this is a GeoSeries in its basic form. It just contains geometries, let me see, a series object designated to store shapely geometry objects. So even that's what the documentation is saying. It stores only shapely geometry objects. So keep that one in mind. And so I can collapse this one and look at a geodata frame. Let me do that in a new cell. So a geodata frame. Okay, so what is a geodata frame also? A geodata frame is like a table, like a really supercharged table. Look at it like a spreadsheet. So if you have something like a spreadsheet, that is, a geodata frame is like a spreadsheet that has extra powers to handle geometries. It has columns like a regular table, as we soon see, but one of those columns, a very special one for that matter, is the geometry column, where the shapes are stored. So you can think of it like, whereas the GeoSeries only holds the geometric shapes or geometric objects like points, lines, and polygons, a geodata frame holds the shapes in the geometry column. So in the geometry column of a geodata frame, you have the GeoSeries objects there. And then that geodata frame, unlike the GeoSeries, which can only store the geometric objects and nothing else, the geodata frame can store the geometric objects in its geometry column, plus other things that you will likely call the attributes of that particular vector data. So, like if you have a world shapefile, a geometry column will contain points showing where each city is or each country is, whereas other columns in the geodata frame will tell you something like the city's name, like the population, like the country, and everything that also describes the data, which we most of the times call attributes. Okay. So what I'll do here is to create a simple geodata frame, usually called GDF, short for geodata frame. You'll see it a lot in today's tutorial. That one too, you can import the geodata frame here, geodata frame. And since this is imported at the top, you have to run this cell again before we can get access to it down there. So I can say geodata frame. And just like the other one, but this one, we don't open square brackets. It's the curly braces. So here is where I specify my other attributes. So let's just take that these points here. Let me give them some comments. This one is a house. And then let's say that this one is maybe a school. And then this last one is maybe a park. Okay. So a geodata frame will store these plus some attributes. You see, I could not add the attributes. I will add them here as Python comments. Pandas or GeoSeries, the Geopandas doesn't know anything about this. It doesn't know that this point is a house because it cannot store anything apart from the geometries. But if I come to a geodata frame, I can specify a column here called name, which, if you are looking at a shapefile, is just the column name of a particular column. And then in here, because I have 3 objects in my GeoSeries that I want to map into my geodata frame, I will give the description here like my house, which maps to the first object, which I said is a house. And then the second one, I can say my school, which also maps to the second object, which I said is a school. And I can say maybe the park. Okay. And so I have a geodata frame here, which has one column called name, which maps to this my GeoSeries points. So here I can now specify that special column called geometry, And then here I pass the GeoSeries. That is supposed to map to these columns in this particular geodata frame. And so I called it places. So places here, just like that. I just hope that it's not so confusing. But if you just type GDF here and you run, you should see it here in a tabular form. So that is what I was saying. It looks like a spreadsheet. And you can see here that I have name, I have geometry. So this, they have been mapped, each of them to, so it just maps it in the order in which they appear. So the first one maps the first, the second to the second, the third to the third, and so on. And I can continue adding other geometry, other attributes as I see fit. Forgive me for my inconsistency in the codes. I think I should be. There's no problem being inconsistent, but I think it's just good to maintain. If it is single quote, single quote. If it is double quote, double quote. So I can have a type column here also. Should have 3 objects. Let's just see what happens if I just put 2 objects or 1 maybe. So here I can just put house and then leave the rest empty, but I forgot a comma here, so I put it there. When I run it, okay, our first error of the day. And it says here that all arrays must be of the same length. So that is why I was saying that I have 3 objects in my GeoSeries and I have to get 3 objects to replace them here. It's either, if it is none, what I can do is to import pandas, maybe as PD. I think that it's built upon pandas, that's why it's called Geopandas. And if it's supposed to be none, I can just say PD. I think I can access the NAN. Is it NA or NAN? Maybe let's try the NA, PD dot NA. And let's see. Okay, so now this one came. So I can specify that it's none. I just don't have to leave it empty. But I think NA, is it not NAN? Oh, it doesn't have that one. Okay, I think it's there. NAN. Okay. It has a particular type that is called NAN. Let me see. Okay, but that's not the focus of this one. Let's just put the NA there. But you'll soon see that if there are some, or even if you load your custom data and there are null values, it has a way of representing them with. I forgot whether it is NA or NAN, but it's one of them. Just that it shouldn't be empty like we saw in the error code. Okay, so obviously these ones have proper names. I just did that for demonstration. So this is a school. And then this one here is a park. Okay, so we have everything in here as they are supposed to be. So that is it between a GeoSeries and a GeoDataframe. And I hope that was not confusing. It's fairly straightforward. Okay. So the next step is to see how we can read data. So Geopandas can read. Okay, so let me just put the title there. Reading data. I think it can read shapefiles, GeoJSONs, and GeoPackages. GeoPackage. These are the 3 I know. If it does read more, I don't really know about that one. But any of these 3, you can pass it in and it will read it for you. So how do we read a file? Well, we will explore several ways of reading files because Geopandas is able to read zip files, is able to read files from a particular URL and all that. So let's first see how we can read a local file. Inside my day 5 folder, what I just did was to copy the data from day 4. I just copied that data over because we'll be using shapefiles and GeoJSONs. So that is the only modification. Apart from that, the only thing I have left here is my day 5 notebook. So the first one that we will look at is reading a local shapefile. Okay, so import Geopandas as GPD, and maybe the file here should be then the path to the file, which I can come here, expand, and then inside SHP, right click on Africa SHP, copy path, relative path should work. When I paste it, you remember from previous sessions that I had to replace it with a dot. So now I have my file here, the path to the file, sorry, not the file itself. All I have to do to read this file is to say, let's assign it to a variable so that we can use the variable later on. So you can call it anything, but by convention it's called GDF, short for GeoDataframe. That should be equal to gpd.readFile. And this read file manager is a very smart one. You don't have to explicitly specify that you are reading a shapefile or a JSON or even the other one, a GeoPackage. It just knows how to figure out which one of them is it that you are reading and pass it to the necessary engine behind the scenes. And it does a lot of amazing stuff. Geopandas is really amazing. So in here, what I want to read is file. I just put it in like this. And I run it, and then, okay, that is the Africa shapefile. It's quite huge, so it's taking some time. Okay, so after 17 seconds, wow. Now the file has been read, but if you want to see it, if you want to see our data, what we can do is to, okay, I will not run this particular cell again because that would take an extra 17 minutes. It doesn't really benefit the stream. So if you want to see the data, like in the form of a table, like your attribute table, just say GDF, that is called the variable that you read the file into. So when I do this, I didn't expect this one to take some time. I honestly didn't expect it to take some time because the file has already been read into memory. So I'm just telling you to bring it up for me. Okay. Or maybe I should just go to Diva GIS. Did I download a file from there the other time? I think so. So Diva, it looks like the Africa shapefile will delay us if we continue using it. So Diva GIS, I want to download a country level shapefile from there. Is my internet that slow? I just hope that the stream is unaffected. So let me just scroll through and download the data for Ghana. You can download for your country or any country of your choice. I'll go with the administrative, and then I will click on this one. It will download it for me. I think it should start it from somewhere. Okay, so this. Okay, now I realize that my internet is very, very slow. Please, is the stream fluent? Is it smooth or is breaking? I would really appreciate your feedback in the comments, so that if I have to refresh my network, I do so. Okay, thank you all. Thank you. It's good to know that it's smooth. So this is the file that has been downloaded. Don't mind my downloads folder. I think it's a bit clumsy and all that, but I even had the India shapefile here. I should have used that one, but no problem. You let me use the Ghana. So what I'll do is to cut it, and then come to the folder into day 5, and then data. And then what I'll do is to paste it here, right click and extract. Once I extract it into this folder for me. Usually when you download from Diva GIS, it gives you in, I think, 3 administrative levels. There is the admin 0, which is the biggest. Admin 1, I think, which breaks it down to the maybe regions or districts, and admin 2 even breaks it down further. So instead of spending a lot of time reading the Africa shapefile, I think I should go with one of these from but it finally popped up, but I'll still not use that one. It's taking a lot of time. So what I'll do is that inside the GHA admin, I will right click on the 01, copy relative path, and then replace the Africa path with it. Not forgetting to replace my day 5. Okay, so now let me add the GDF here, the GDF. I don't need it in this particular cell. So if I run it again, this one did not really take long because this is just a single file. Is the biggest, the admin 0 is just a single file for the whole country. And we will get to plotting very soon, but let me introduce you to this thing that if you have your data and you want to see it, you just call, instead of just calling GDF, just say GDF.plot. We will dive into the plot function very, very soon. But this one will plot for us. Okay, so I see it here. This is the admin 0 shapefile, the Ghana shapefile. And if I read the one, you should be able to see some divisions. I don't know whether you see it on your screen, but there are some thin white divisions here that divides Ghana into the respective regions. And the admin 2 is even it goes much it gives much detail, so I can see Ghana down to its districts, local assembly levels. So that is it. How to read a file, and also all the pandas. If you are familiar with pandas, so this is the table here. And I come down here, I see that it's 137 rows by 12 columns. All the operations that we can perform on pandas data frames, we can perform on this one too. So if I, for instance, say I want to see all the columns, I can say print gdf.columns. And then I see that if you forget about the index and the type here and focus on what is in between them, you see that we have a column called ID 0, ISO, name 0, name 1, name, and all that. You may have to refer to the accompanying. They usually have a, it should be in the license, no. But I think on their website, they will give something to explain the various columns. It should be somewhere on the website. That is not the focus for this tutorial, so I'll not spend time searching for it. But if you download your country data or such a structured data like this one, I think it shouldn't be so difficult to know what each column contains, even if it's not explicitly stated. Because if we, for instance, go to GDF, you see that the name 0 looks like it's constant throughout, specifying the name Ghana. And the name 1 looks like it's also constant, but it's not. It changes somewhere. So those are the Ghana regions. And the name 2 is the districts. And so depending on your country and how it is structured administratively, these columns will contain something different. Yeah, but for Ghana, that is the country, region, and then the district. And I think that should be, yeah, that should be all. Okay. And one of the cool things that you can also do is to say gdf.describe. I find this particular function Very, very useful. And what it will do is that to give you a quick statistical overview of your data. So you see here that there is the count. I have 137 items in there. This is the mean, the standard deviation, and it gives you, so the mean for the ID0 column, the mean for the ID1 column, the mean for the ID2 column. I think those are the numerical columns. If you have other numerical columns, it will give you the statistical values of all these ones out of the box. So the 25th percentile, the median, which is also the 50th percentile, and all the rest also there. Okay. And one cool thing about this one also is that if once you read this shapefile, unlike let's say you read it into QGIS, if you make edits to the data you have loaded and you save it, you overwrite the existing data into a new one. But this one, this file that you have read here remains unaffected. What we have here that we are working with, this GDF object, is a file that exists in memory. So it's a memory file that we can manipulate anyhow and then later on save it to a new file if we want to. So that is also one of the cool things that you should consider using Python to do some of these things. You do all modifications and you are not afraid of losing your original data. Okay, so this is how we can read a local shapefile. How about reading a local zip file? Okay. As I told you that Geopandas can also read zip files. So let me put a mark down here. Local zip files. But those zip files should contain either a shapefile, a GeoJSON, or a GeoPackage. If you have a GeoJSON, just plug it here. It will work like this shapefile is also working, but I don't want to spend time doing all of them. You just try it at your end. It will work. If you have any error, you can put it down in the comment section and then it will be addressed, or you put it on the page also and it will be addressed. So the same convention, let me just copy everything here, paste it. And then luckily I have this Ghana shapefile here. This one here. So I'll copy relative path and replace this one with it. Not forgetting to replace the D5 with dots. And so if I say file, let me change the name so that you don't think that's reading from the other one. So let me just call this one zip file. And so this one to be zip underscore file. And then let me change this one so that I don't also think that it's reading the first one. So this one will be zip underscore GDF. And you see that it has read the file. But it only read the first one, which was inside there. And not the... So it went through it. When it saw the first shapefile, it read it. But we have 3 shapefiles in there that we can read from. So let's see how we can access it from the other ones also. Okay, so that one I have a zip file here. And this is how we do it when the zip file is local. I will also put quotes here, convert this one into an F string by appending it, prepending it, sorry, with a lowercase f, and I type zip just to make Geopandas know that it's a zip file. And look at this carefully. I put triple forward slashes, or depending on the separator for your system. Some of the systems use the backslash as the separator. Sorry. The backslash. Okay, my keyboard configuration has changed. But the backslash, some of them use the backslash as the separator, others use the forward slash. If you use the forward slash, use the forward slash. If you use the backslash, use the backslash. You see, mine is the forward slash, so I use the forward slash. 3 of them, don't forget. And then I will pass in the path to the file. So in here, I'll plug the zip file. So that is the path to the file. And then I can read it. Okay. This one too will work. In fact, okay. I don't know why it didn't work, but it's saying that fine, it didn't find something like this. Well, that is because I wanted to add something else that I forgot. We saw from the beginning that it's able to read the zip file. So assuming it's only one file that is in there, so only one shape file that is in there, then reading it this way doesn't really make sense. You can easily, let me comment this out. You can easily read the zip file here like this. You have only one file in there, then you don't need to go through all this weird syntax. You just read it like this, and then it will read it for you. But if you have more than one file in there and you want to specify a particular file, like in my case, I want to specify this gha-admin2.shp. What I can do is to make the syntax a little weird like this, which should not become weird to you if you use it for a number of times. And then I can put the my separator again and paste the file name. This time around, when I run it, oh, I was not expecting this error. Let me see. It says does not exist in the file system. Okay, so it looks like something really is happening. Well, I think the first one also was not supposed to throw the error. The error is coming from this relative path. So let me come back here and then get the absolute path, which is the copy path, and then paste that one in rather. Okay, now let me run it and see. Now, when I pasted the absolute path, not the relative path, the absolute path, it worked. So the absolute path is just the path from your root directory. Now, if you are following this stream on Windows, this stream is being recorded on Linux. If you are following it on Windows, you probably will have something like this. Let me paste this line down here. For the Windows users, please look at me. Mac, you may have your own work like this. But for the Windows users, you usually have C and then colon. And is this C something, C colon something. Before you come to, I think users, something like this. I've forgotten the exact C, the structure, but it's something like this. C, then slash something, and then users, blah, blah, blah. If you put the whole part, including the C there, it may not work. So what you have to do if you're on Windows is to delete everything that comes before the users and make sure that your string starts from the users. And in that case, it will work for you. So for the Windows users, let me comment it out like this. I will not delete it so that you can type and follow. But for me on Linux, this one works for me. So Mac, I'm not streaming from a Mac and I don't have one with me now. So I don't know how the part will work, but it should work like this for you. Just copy and paste the absolute path. So that is it also when you want to read local zip files that have multiple files in it, you do something like this. So if I change this one to 1 and run it to read the admin1 shapefile for me. Okay, that is great. So that one too is dealt with. And the next one that we are looking at is reading files from URLs. Geopandas can read files from the internet. So if you have a file somewhere on the internet, reading files from the internet. Okay. So the normal stuff, let's just copy everything here. Forgive me for copying and pasting. I think you should speed things up rather than me typing redundant stuff. So I'll change every zip here to URL. And then this one, let me delete it. Let me just clean things up for now. So here I'll pass URL file like this. Okay, so obviously this is not a web address. So let's visit our browser. I have this site here that we can read things from. It is called geojson.xyz. geojson.xyz. Okay. So it's a simple open source website or content delivery network and a command line. Okay, wow, they really even have a command line interface for the fast access of GeoJSON data for web mapping examples and experiments, which is exactly what we are doing. So you see that they are getting their data from natural earth. You can read about them. They have quite they have data that you can download and use for your work. And so all of them too here are in the public domain, free to use. And what I want to do is that you can come here, you just pick one of them. I want something that will look like this one is like regions. I don't know which regions they are, but unless I have to zoom out here a bit because I want you to see the URL also. You see that every file here has a URL attached. And where's the one I wanted to download? Regions. Okay, I want polygons. That's why geography regions poly. Okay, this file is 2.43 megabytes. Shouldn't take long to download. And so instead of clicking the download here, or I think this same URL for the download is here. If you double click on, or if you click, I think if you click on any of the rows, to give you this. Or let me just use this one. It will give you, it will expand to give you some things like that. A map here should load, but I don't know why my internet is that slow. Okay. Oh, no. This is not something I want to. Let me just get this one. The polygons. Okay. This will take a long time to load. It's the whole world. Forgive me. Let me just look at. This should look like state lakes should not be something that big. But what I'm looking for is this direct URL. So if you have a file on the internet, usually it will be sitting on a server, some server somewhere, and then it will end in the file type, which is GeoJSON. So I've copied this. I will come back to VS Code and paste that URL in here. Quite a long one. And then when I run it, it should read the file for me. Okay, I was just looking something that should be simple. Let me go back and see. This one, the file size is small. Let me change it to this one and see. Okay. We even have an error. Temporary failure in resolution, in name resolution. That error shouldn't be from our side. I don't think so. Let me change this URL and see. Okay, I don't know why the URL from this site is not working, but let's go back to Diva GIS. Maybe theirs will work. And so instead of downloading the file, I'll right click on it and then go to copy link. That will also give me the file link. And then when I come back to VS Code, let me replace this path with that. So if the file that is on the internet is even a zip file, it can read it for you. Okay, that's quite unfortunate. Wow. It looks like there are not so many simple files on the internet. It now has to read the admin 0, admin 1, admin 2, and all that. But you can see that after I successfully downloaded and extracted it, however it does it before it reads it, I don't really know, but I know that it reads it and that this one has been read successfully. So there was probably a mistake with the URL earlier, which I don't know why, because when I was testing URLs, that one worked. So this is also how to read file from a particular URL. Okay. The next on our list is also that Geopandas also comes with its own data sets. So we can get some data sets inside Geopandas for free. So Geopandas data sets. And let's see how we can read those ones. So import Geopandas as GPD. And then if you want to see the available data sets in there, what we can do is to say print and then gpd.datasets.available. So this one will give us all the available, GPD. Okay. All the available data sets that come with Geopandas. So if we want to read one, let's say we want to read the cities, because that's points and it shouldn't take long. This lower resolution, I think, is for all the countries in the world, and that should take some time given the previous experiences. So what I'll do is to say maybe cities GDF and set that one equal to. Now we are also reading the file, so it should be gpd.read file. And the file that we want to read is gpd.datasets.getPath. And then we pass in the name of the file we want to read. So I'll just copy this name here and then paste it in. So gpd.read file, but which file do we want to read? We want to read from Geopandas' own data sets and the one called natural earth cities. So if I go cities, GDF, now this one did not take long. So I see that I have cities here in the world to work with. Let me plot it and see. Okay, I think it's all the cities in the world, but we will go to how to customize these plots, but don't worry for now. We get them very soon. But also to show you that there are some stuff that come with Geopandas. So this one, I think this one is, I want to, I think it's New York something. Let's plot this one and see. I think this is somewhere. I don't know, but I think it's, you can read on it NYBB Geopandas. But that is a polygon that does not really take a lot of time to load. So let me inspect it and see. Okay, borrow name, and then borrow code. Okay. Okay, I don't really know what these are and which. Brooklyn, Manhattan. I think these are in the United States somewhere. Yeah. So you can read about that particular data set. You may not need it, you may need it, but if you ever need it, this is how to get it. Geopandas' own data set. Okay. So now let's look at how we can select and index data. All right, I'm about to do something that will take some time, but we will still do it. So that is I will read the world shapefile. So indexing and selecting data. So we read the shapefile, this one that comes with Geopandas. We read the world one that I did not want to read at first. But that one's name was Natural Earth. Okay, so I already have Geopandas imported. I've run it several times, so it's not necessary to import it in every cell. If I hit run, oh, this thing has actually impressed me. I thought it would take a lot. So you see that this one is a world data set which has a population estimate. It can tell you the continent, the name of the country, and I think these are ISO something. I don't really know what they are, but these three are of great importance to me: the population estimate, the continent, and the name. So let's just say that we want to only fetch, and we are working with population estimate. So we want to only fetch the population estimate. So we can come here like, so pop estimate, set that one to be equal to world. Now this is how we do the subsetting. World or selecting. Others will also call it indexing. You can do complex indexing here if you are familiar with pandas, but this is not a pandas tutorial, and so we'll keep things very simple. But what you do for the indexing is that you first call the GeoDataframe like this, and then when you open the bracket, you call it again. You say world. Maybe today will not allow us, but tomorrow we should try and explore some of the complex ways you can perform queries with your GeoDataframes, like how you do the selection by attributes and selection by attributes in your GIS softwares. You can do it here, more complex, and querying, you can all do that in Geopandas. So here I want to select it where the I want to select the population estimate column. So that will be POP EST like this. And so when I come here and say maybe POP EST, we have an error. Key error, none of index. Okay, the data is here, but why is it not bringing it to us? Well, I got the column name wrong. Let me see. Okay, let me see the column name here. POP EST. Okay. I think this is a different type of query. Let me just put in POP underscore EST and see. Okay, that seemed to work. Okay. If I'm fetching only one column, it's not necessary. It's not necessary to put that one. Will only return a series like this, so it's not necessary to do those nested fetching. Where I do those kind of nested fetching. So if I want to also call more than one column, I think if I remember correctly, there was the country column also. So I can just say country like this, and then it will fetch, I think the country is not in index. Let me see the name again. Okay. Oh, forgive me, I'm not able to keep. Okay, we have. Okay, it's rather name and continent. Okay, so let me just copy this one, paste it here. Continent, like this. Okay. So if I comment this one out, uncomment this, and then I come back to uncomment this also. You see that now I only have those 3 columns. One of the things I have not shown you that you can do is to just say pop est.toFile. So this is the writing file. It's supposed to be later, but I think it can also be here, no problem. So that one dot to, you can even make it to CSV straight. So if you want a CSV dot to CSV, all you have to do is to pass the name of the CSV file here. So I can say world, I want to store it in just the same location. So world names dot CSV. Before I run that cell, let me open up my Explorer for you to see that apart from my Python notebook and the data folder, there's nothing else there. But I run this one and I have my world names.csv file here created for me. Well, I don't have an extension that will prettify this CSV, but you can see population estimates. Apart from the index column, I'll not install this. Apart from the index column that I did not specify that it should be false, the rest I fetched, they've all been saved to this CSV nicely for me. So I can say here that index is false. I don't want the index to be saved together with the file. When I run it, now you see that the index is not there. Okay. So you can save any of your analysis to file. And if you want to save it to another type of file, I think there is a to file also there. But in that case, you may have to specify the particular driver you are using, whether GeoJSON, whether a Shapefile or GeoPackage, you have to specify that one. Okay, so this is one of the ways to call for things in there. The other one, let's say we want to call only, now if we do this world gdf.plot, okay, I should call it. You see that it plots the whole world for me. Okay, let me just say that I only want to plot Africa. And so I want to only select all the countries in Africa and Africa alone. What I can do here is to say maybe Africa. Let me get rid of this one. We don't need it again. Africa. That one equal to world GDF. And in here, I specify world GDF again and say that where the continent column is double equal to Africa. Okay, so I know that I've typed a lot of things here in a very short time, but this is the method of selecting data that I even tried at first. It skipped me. I tried this one at first. This one, if you want to select based on the value in a particular field, you use it this way. So in this one, we are subsetting the whole of the world geodata frame, but we want it only where the world geodata frame continent column, the value is Africa. So now if we come here and say Africa dot plot, you see that we have only Africa in here plotted for us. So it has subsetted the African part of the data for us. And it's just so like that. So if you have it and you want to save the Africa shapefile, you can just write .toFile and maybe africa.shp, and you have queried it. It's just one of the selections you do in ArcGIS where you say that, okay, if the continent is Africa, select it. That is just one line of code here. Just one line of code. So that is also how we do the subsetting and selecting data. This is not the most advanced form of doing it. As I said, we will have to explore that one in subsequent sessions. But let us look at the last two on our list. Today is plotting and interactive mapping, but we will not go deep into them because of time. And so let's look at the plot. Okay, so there's a question. Is plot method not reading the CRS or the attributes table containing the Cartesian coordinates? Okay, what is happening here? If I call .plot, what is being called is the matplotlib.pyplot. If you are into data science, you should know the matplotlib package. Okay, I don't have to visit it, but let me just matplotlib. Okay, I even searched for it wrong. But let me search it in this bigger one so I can see the text clearly. So the matplotlib.pyplot. This is what Geopandas is using. Okay, that is also taking a while to load. But you can read more about the matplotlib.pyplot. It's used to plot stuff if you are using matplotlib. And it can, as you can see from the documentation here, when you want to plot, all you have to do is to pass in an x and y. So what is happening is that Geopandas is taking your geometry column, the coordinates in there, and then passing them to the pyplot as XY values. But of course, all your other data like the name, country, and continent, and estimated population column, they are all kept safe also there. So they are not lost. You can actually use them. We will see very soon when we are plotting some simple choropleth map. Okay. I hope I've answered the question well. So we have been seeing, so where is this one? Plotting with Geopandas. Okay, so what I'll do here is, okay, I'll be taking the same Africa. So let me just copy this code. Because it's already saved in here, I don't need to. Or you let me still do it so that the cell, I know that the cell is for this. So I will still have to come and copy. Okay, I even made a mistake here, but it still worked because the variable is already in memory there. So that should be geopandas.gpd, not god. Okay, so I'm reading from the natural earth data inside Geopandas. You can read your own custom data. That is completely fine. We just need data. And I'm subsetting the African continent. And so if I call africa.plot and I plot it, you see that I have a plot here. But whatever that we can pass to the matplotlib.pyplot, where is that manager? Whatever argument we can pass to this matplotlib.pyplot, we can pass it to the geopandas.plot. So once again, I know that the documentation, if you're a beginner, is not the best place to start. So let's come back and let me show you what I have learned so far and what is it that you can pass. Okay, so first what I want to do is to print Africa.columns because I'll need some of the columns in there. I don't want to be forgetting it like I did. So I now have all my columns here listed. Fine. So if I want to plot a choropleth map, I can specify the particular column I want to plot. So I can say column and set it equal to the name of the column. Maybe let me pick name. Because continent is just one. If I choose continent, it will just show one. And that is it. I have my choropleth map here. It's as simple and easy as that. And if you want to change this color code, that's one too. So let me give a comment. Choropleth maps. And then if you want to also change the color code, it's called CMap. I don't know whether it's short for color map but it's called CMap. There are lots of them. In fact, let's come to Matplotlib's website and see. we have a universal search here? Okay, search the docs. Oh, and then let me say CMAP. Yeah, I want to get all the colors that are available. Okay, so that is not available here. So mat plot lib CMAP values. Let's search for something like that and see. Okay, it's not really coming. I don't know why. But I remember one that I like to use a lot, Viridis. This is that one. There is, I think there is winter. And there should be, I think Inferno 2 is one of them. Okay, and I think if we intentionally put something bad here, something wrong here, it should give us all the available. Good. It should give us, oh, okay, great. I don't even need to search the internet. Just put a wrong value there. And to tell you that wrong is not, I'm not saying just type wrong. Just type something that is invalid. It's not valid for CMAP. These are all the supported values. So you can copy them somewhere. And if you want to experiment with all of them, you can see that it's quite a long list. So you can just, let me just randomly pick this one. It's a long list. So just type in something wrong. It will just give you all the correct ones. Okay, so let me put this one in. And this one now, it should work. Okay, I don't think I like this color. Let me go back to my Viridis. That is by far my best color. Okay, and so this one too is to change color. And then I can also, if I am plotting a choropleth map, I can have a legend. So all I have to say is to say legend equal to true. Once I pass in this, so add a legend. Okay, so not the best of view, but we still have our legend. Well, today we may not be able to know how to customize this thing, maybe put it in double columns or multiple columns, but at least we know that there's a legend. Great. And you see that the plot size is not really the best that it can be. So we can also pass in an optional figure size. So we can say fig size, which is there for the figure size. And this here we pass in a tuple in inches. So if I say, looking at the shape of Africa, I can say is portrait. So let me just pass in 16, maybe 8 in the X or something like that. And then maybe, let me choose 16 just to, okay, so now you see that it made it larger, but it was still not so large to even accommodate our legend. Okay. Okay. So you can also change the figure size here. And then the other things that you can do also is to maybe add a grade, set X limit, set Y limit. If you are plotting a point, you can say marker size to show the size of the point. And you can give a transparency to your geometries. That one is, let me see, this is increase canvas size. And then let's look at the edge color, which is If I choose, let me choose a color that will make it very visible, red. This one is the boundary color. Boundary color. Now you see that all our shapes have an edge color of red. And if it's a line type, this one is polygon. If it's a line, you can specify the line width. You can also specify, if it is a point, you can also specify the marker size. And let me just try, the alpha should work for all of them. So let me come here, put a comma here, I forgot it. And then say alpha, which is just the transparency. If I put it to 0.2, which means I want it to be 0.2%, sorry, 20% transparent. So transparency. Now we almost not see our shapes. So if you can see it clearly, we are actually building a map. Small. We have our legend. We'll be able to add other things also here. Even we can even in our own way add a north arrow. We will look at all of them. Maybe not today, maybe tomorrow, and all that. So we are gradually building a map. This one can easily be saved. We can, of course, you have to assign it to a particular variable. Then we save it as a JPEG or PNG. So that you have your map. So other things that we can explore, maybe let's add the last one, which is the grid, and set that one to be equal to true. So add a grid. Okay. Patch collection.set got an unexpected argument. Okay, so you're saying that the grid, but that should be, well, this one should work because I think matplotlib.pyplot accepts grid. So why is that this one was not working? Okay, there's another way of doing the plotting where we declare a figure and an axis. Maybe because this one really is not explicitly giving an axis, that is why we cannot add the grid. But tomorrow, when we take things further, we will actually define figures and axes, how we can plot multiple objects on the same figure. So if you have a map, maybe a time series map, we want to show 5 or 6 maps on the same document, you can put all 6 on one. And I think that is where we can work around the grid and all that. Maybe it doesn't work for single ones like this, or maybe that is not how and where to put it. I don't really know why the grid is not working here. Okay, so you can explore other things. Also, once you go to the matplotlib.pyplot page, that is if and only if you can read the documentation. If not, you can explore with these ones that are here. Make sure you can change names, give legend, figure size, and all that. And let's see how that one will take us to. Even VS Code allows you to save it. I think when you put your cursor on it like this, it can save it for you. And this one is expand the image. Expand it also here for you. Okay, so you can do all those things also. And so let's go to the last one of the day, and that should be interactive mapping. Okay, so that one permits me to use this same code. And all you have to do to enter interactive mode is to say the particular geodata frame that you are working with. So in our case, Africa.explore. Once you call the explore, behind the scene, it will call folium. I think so. And then that one will put your map in an interactive mode like we saw folium do for us. So this map 2 is interactive, automatically has the pop-up for each and every one of them based on this based on the data in our shapefile. So it just looks at all of them and then uses them to give you the particular shapefile. So the particular pop-up. Okay. So, but if you want to override this tooltip here, you can easily do that. So let's come in here and say tooltip. Sorry, tooltip equal to, and then maybe I can now say the column name is, I think it's name. Okay. Yeah, it is name. Oh, not tooltip, tooltip. I forgot the L. So now when I put my cursor on it, you see that it only gives me the name, not everything that is inside the shapefile. Okay, so if you want to also concatenate other stuff, maybe I think you can turn this one into an F string and say maybe name, and then I think the other one we can put a \n. Seriously looking for where my backslash now is. My keyboard configuration has changed. Forgive me for that. I think I have some here. So, oh, these ones are /. I wanted to insert the new line character and then okay. I wanted to insert the new line character so that I can bring this one there, but okay, I don't even have to put it in an F string. So it's supposed to be name like this, and I can insert the other one, but I'm not able to get my \/ here. Okay, so this one will give us just the tooltip like that. And if you also want to show all the values inside your attributes as a pop-up, you just have to say pop up equal to true. And when you run it, when I click, it's that I see all the values in there, the pop-up as true. So with the pop-up as true. So that is also one of the ways to add pop-ups in there. Okay. And other things that we can also, we can also change the color map here if there's C map. And then some of these things, if you are typing them, you not get auto completion because they are not really passed in directly to the explore function. They are passed in as extra arguments and keyworded arguments. So just make sure that you are typing it correctly. Here, VS Code will not really help you with the auto completion. There's one C map called set1. And I have it here, but it will not work because I've not specified that I want to plot a particular column. So the C map only works when I'm doing choropleth maps. So column here now equal to name. And this time around, my C map should come. You see that my C map came. I don't think I really like this color, but no problem. It's just to show you that you can have something like that. Okay. If there are other things that you can also pass in, let's say, for instance, I want to give a black outline to all of the polygons. I can pass extra styles into what we call the style keyword, KWDS, style keywords. That's how I choose to remember it. So style keywords, that one is a dictionary. So we can open a dictionary here and say that the color is black. Okay, so when we run it now, that should put a black color, a border around all of the polygons for us. So the possibilities are almost endless here. You just have to explore, and we'll try and go deeper tomorrow and see all the amazing stuff that we can do here. So all the stuff that you do in Folium, you can repeat them here, just that Geopandas lets you do it in a more easier way than you may do it in Folium. Okay. So as always, I think this should be the end of our tutorial today. If there are any questions I have to address, I will do that in the next 1 minute. Other than that, we close chapter on today and anticipate for tomorrow. How to remove from the map that scale numbers on the left side. I don't think I really get. Please, which numbers are you talking about? Can you? Oh, okay. This the axis, these numbers here, they look like the coordinate. Well, I think we can. If I'm following the matplotlib conversion, let me just say axis equal to none and see. Okay. Okay, I'm really not able to pass in some of these things here. But there's a way to do it when we create plots, figures and canvas. Let's see how we'll do that tomorrow. Because I don't want to initiate another session of Geopandas here, or maybe plotting here. That is where we have to create figures and access on the figures and all those ones. So please, let's look at that one tomorrow. I'll keep it in my notes and I'll hit on it. I'll not forget. You can remove it from there if you don't want to. If you can actually even customize it. I've done works that I customized it and added degree east, degree west based on whether the value was negative or positive. So I think I will teach you how to do all of those things so that you make your map as professional as possible. Yes. So permit me to do that one tomorrow. Okay. So are there any questions I have to address in the next 30 seconds? Other than that, we will call it a day and anticipate for tomorrow. Okay, so there are no questions. Thank you very much for joining today's stream. Also, I hope today was great as always. Have a great day, all of you who are still in the day. And have a good night, all of us who have to retire to bed. Make sure you keep on practicing as much as you can. And so until next time, it is goodbye.